In this video, we will discuss the formulas for the sum of n terms of a geometric progression. Right now, these formulas are the three different formulas based on the value of r. Right. So the first condition is when the value of r is less than 1. In that case, the sum of n terms of a geometric progression is given as a into in the bracket 1 minus r raised to n divided by 1 minus r, where a is the first term and r is the common ratio and n is the number of terms you are considering for the sum. Also, the same formula can be considered in a different way. For example, in a sum, if we've been given the last term or the nth term of the series, we can also find the sum of all the terms in that case by considering this formula, which is Sn is equal to a minus L into r upon 1 minus r, where L is nothing but the last term, or in this context, we could also consider it to be the nth term, or Tn, if you are considering the sum of n terms. Right. So this was for the value of r being less than 1. There are similar formulas for the value of r being greater than 1 as well. The formulas are as follows. As you can see, for the value of r being greater than 1, Sn can be calculated as a into in the bracket r raised to n minus 1 upon r minus 1. And if you've been given the last term once again, so we can calculate Sn, the sum of n terms, by Lr minus a upon r minus 1. As you can see, both of these formulas are rather similar to each other, and in all honesty, we can use either of these formulas, irrespective of the value of r being greater than 1 or less than 1. But in your textbook, they have given two separate formulas, so we discuss them as such here. Finally, now, so if you see there's r less than 1, r greater than 1, now the formula that we'll discuss is for r equal to 1. We can't, the formula that formula will not be similar to this, because if I put r equal to 1 in the denominator, you see it becomes 0, which is not really conducive. We cannot divide by 0, right? So in the case where r is equal to 1, also understand, if r is equal to 1, that means the common ratio, the ratio between any two successive terms, or a given term and its preceding term, is equal to 1. That means that they're the same term. So if a is the first term and the ratio is 1, a into r becomes a again, and a into r square also is becoming a, and a into r cube also will be a. So we'll just have a bunch of a's n times, and so the sum of n terms is nothing but n into a, right? So these are the formulas that we have in geometric progression regarding the sum of n terms of a GP, and they vary slightly depending on the value of r. And depending on the given information, we can use either of these formulas. If the last term is given, then we can use a minus Lr upon 1 minus r. Or if the first term, a number of terms, and the common ratio is known, we can use this particular formula here, right? In the next videos, we'll be doing sums where we'll be using these formulas to find particular values, right?